different topic. Keep talking about the puzzle pieces, how we're going to work on each little puzzle piece to fit everything together. Well, we got another problem domain today, different type of problem, just as real a problem as the naming problem. A different group probably was assigned to go off and work on this one. So we're going to take this problem, we're going to kind of work our way through this particular one today. How many of you all have had the great fortune of being on I-35 just east of the campus here, say 30, 45 minutes before game day? Anybody like that? Okay. Or 30, 45 minutes after the game. Either way, you're not going very far, very fast there. Actually, about a year ago, I was doing a wedding down in San Marcos or Kyle, somewhere down there south. I was listening to the game coming back. I live north, and so it was just getting close to the end of the game, and I was speeding, trying to get down just so I could get past the stadium before the end of the game, just to get away from it, just so I wouldn't be caught up in the traffic. Well, if you are on Guadalupe and need to get to San Antonio Street, one block over from Guadalupe, in the middle of that traffic on game day, anybody think if I'm on Guadalupe and need to get over to San Antonio Street, I'm going to take the route that puts me out on I-35? Probably not. Wouldn't be that wise. Why not? Because you don't need to. Number one, you don't want to get involved with all the traffic that's out there. And number two, no one would really appreciate the fact that you're adding to the problem by putting your traffic out there, putting your car out on that when they already have enough traffic there. So wouldn't it make sense that we would do the same type of thing in the internet? Michael's got an IP address right here, and I give you an IP address of some little farm in Sweden, some server somewhere. That little server on a farm in Sweden has 1 out of 4 billion IP addresses. Did it ever occur to you to think, how does it find it? How does it get there? Does it just hopefully just throw it out on the internet and somehow or another that little got over across the Atlantic into Sweden and just kind of accidentally found it? We can't get across town without a map, without structure on how we're getting places. So wouldn't we need some sort of structure on how we move around here? We've got decentralized functionality. I'm going to kind of expand that. That's one of our 6 objectives, but I'm going to expand the definition of functionality to include decentralized traffic. And when I refer to traffic on the internet, I'm referring to packets. Packets are our cars. Same type of thing. The more packets you've got on a particular wire, the more cluttered it's going to become. So let's imagine, I don't know, who's got a laptop? Julianne's got a laptop. Michael's got a laptop. You're 2 people apart here. You're going to send something to her computer. Do you really think it needs to go out in the hallways, go up on all the floors of CBA, go across to Jester, down to the engineering building, and out to the Pickle Research Center, all around just to get between the 2 of you there? Obviously, conceptually, you'd say, no, I can see her. See, it's that close. I don't have to worry about it. Just send it right over there. Well, it makes sense to say we want to keep local traffic local. And if we don't have to go out on the major thoroughfares, why do we go out on the major thoroughfares? Everyone in this room would agree that that's conceptually the right answer. But what we're going to have to do is figure out a way technically to cause that to occur and to control that. Traffic clutter is a real problem. Traffic clutter meaning packets, too many packets on the internet, just like game day. Think back with me in the early 90s, IBM was just getting into TCP/IP. I mean, research had been doing a lot of work with it. It was becoming more prevalent in our big development labs. My team wasn't using it, but we were still using LAN server and getting files off the server and print server and things like that. And frankly, the teams that were learning about it were still just learning, and I'm not putting them down. It just no one knew what we were doing at that time. There was all kinds of configuration problems, and it was real rough. Well, periodically, we'd be trying to get to our servers just to do our stuff with the standard is file sharing, and it would literally, the whole network would go to its knees. I mean, it'd take 15 minutes to get a file back from something like that. And so we'd typically go get coffee, and he's standing around complaining. And there was a guy that worked in our area. He was our administrator, and he used to shake his head and say, "More TCP storms." I don't know if he coined that term or if it's something that's been used in the industry or whatever, but it fit. Because what was happening was all these people that weren't really good yet, still learning how to configure TCP/IP, were having let's say a game day problem with traffic. They were not able to control the traffic and keep local what needed to be local, and everything was getting out on the main thoroughfares. Well, basically he called it a storm, but what it meant was no one was going anywhere. They had to come up with a way. We have to come up with a way to solve this problem so that the traffic needs to go where the traffic needs to go and no further. Because the last thing you want is these out of control traffic packets or packets flying all over the world, everywhere, all the time, because all of a sudden it would be permanent traffic jam everywhere. We got to solve the problem. First thing we got to do is divide the network into localized subnetworks. Now the official term is subnetwork, but no one uses that term. Everybody uses the term subnet. And you will hear that term. It is in red. Subnet is a very, very common term. Think of that. Think of a subnet as our neighborhood, our room here. We would be a subnet. And we'll talk more about that in a minute here. Traffic destined for a computer inside the same subnet. Michael sent it to Julianne. Those two computers, sending back and forth, would never leave this room. Traffic that needed to go to Facebook or Yahoo would have to leave the room. Very simple concept, but how are we going to make it happen? If we're going to divide our room from the rest of the world, our subnetwork from the rest of the world, we're going to need to have what's called a gateway. We got our door back over here. Pretend that other door doesn't exist. We've got one doorway out of this room. We're going to have to station somebody at that doorway, and it's got to be a traffic cop. And that traffic cop, or it's called a gateway, gatekeeper, has to stand at the gate and keep traffic inside that needs to stay inside, can stay inside, and only the traffic that needs to go out goes outside. You paid a lot of money to come to a business college and you didn't know you were going to get a lecture in Roman mythology. But you just never know what you're going to learn when you come to my class. Roman mythology. There was a Roman god named Janus. Janus stood for keeper of the gate or keeper of the doorway. Janus had two faces. Because if you are a gatekeeper, you need to be aware of all of the activity outside, so you need to have a face looking out. But you also need to be cognizant of what's going on inside the room here, so you have to have another face looking inside. So I like to think of the gateway as Janus, because the gateway has to serve two functions. It has to look up and outside in the hallway and outside, and it also has to look inside our room here. So I'm going to refer to Janus quite a bit today. Gateway is a door. Just keep Janus in mind when we talk about gateways. Here's a picture of it in more technical terms. We've got 3 subnets. Now this is our classroom, this is a classroom down the hallway, and this is a classroom other side of the building here. 3 different classrooms, 3 different subnets. Each one has a gateway, and then we have the outer internet here. So this little subnet, traffic flowing within that classroom stays in that classroom. Traffic flowing within this classroom stays here. Traffic that needs to go between the two can come out and back around. But that's probably less traffic than if everybody's sending everything to everybody else and it all is just global and everything goes everywhere. You follow the basic concept of subnet. Any questions about that? Yes.
So if you're sending somebody an email, it's not going to their IP address.
Well, typically email is not a good, because email always goes to a server.
Right.
So but peer-to-peer is not really the best way to think about it here. But let's just pretend in my example, Michael was the server. Michael was an HTTP server, and you.
I'm talking about files from servers to.
Well, yeah, I'm talking about any connection where you make a request. If you were running an HTTP server on your machine here, she could get to it. There's not any peer-to-peer type things, but I'm talking about just anything, anytime This is more generic than just peer-to-peer. This is anytime I got a source and a target for a request. And if they're in the same subnet, they stay in the same subnet. Any question? Yes?
Does that apply to saying, like, here, if we're accessing the McCombs website, we're on the same?
Well, now where is the McCombs website happen to be just on the other side of that wall? It might accidentally be on the same subnet with us, so it wouldn't go out through the door. Probably not in that case. If the server was literally sitting in this room here, we could all talk to it and Janice would be sleeping over there. Where our subnets divide and everything inside, it's easier to think of it in a physical situation. Subnets, they don't have to be physically, they're very close, but you and your next door neighbor can have two different subnets and two apartments or whatever. So hang on to those. Come back to me if you have other questions. I'm going to cover this several different ways today. Looking inbound, the gateway is simply another computer with an IP address on the subnet and an IP address on the network. Looking inbound, think of it, again, two faces. Janus is two faces. Looking in, it's a computer on our network. It's another computer, another network card on the outbound network. So literally two computer cards going outside the room, one coming inside the room. And the software inside causes it to jump between the two. The IP stacks in every machine must make a decision. This is a key point here. Every machine, every laptop that's open in here in our little subnet, every time you send a request, any type of request, you obviously leaving your computer, you're going to make a request. You need to decide, is the target in my neighborhood? Is the target I need to send this to, I've got an IP address, the target's an IP address. Is the target IP address within our little sandbox here where we're playing? Yes or no? If it is, you send the request directly to that IP address. End of discussion, life is good. Because we're all in one little sandbox. If the answer is no, that is not, the address is not in my subnet, within my range here, I'm not going to send it to the world. I'm going to send it to the gateway. The only things I know is the gateway and all you guys. One or the other. Either I'm going to send it to one of you because that's the target, or I'm going to send it to the gateway, and the gateway is going to act on my behalf and send it on up from there and handle it. So that's the first decision we got to make. Now, how are we going to do that? Now, conceptually, everyone's probably been pretty much along with me on this. But now we got to get down to ones and zeros. And how's the computer going to decide whether it is in this network or not? I got two IP addresses. How do I know whether my IP address and the target IP address are in the same network, in the same subnet? Well, there's something called a subnet mask. Got to take just a little bit of time here and talk just a little bit of Boolean math just so you understand how the mask works. The mask itself is another 32-bit number. It's ones and zeros. But just like typical mask that you see, a mask lets some things through and blocks other things. So what we're going to do is we're going to build a mask. So anyone ever taken psychology and taken where you have Boolean logic, ands and ors, functions and things like that? The and function is very straightforward. Logical and says, if it is 3:30 and everyone is in the room and seated, we will start class. And if it is 3:30 and everyone is in the room, we will start class. If it is not 3:30 and everybody got here early, we're still not going to start class. If it's 3:30 and I can't control you and you won't sit down, we're not going to start class. It's an and. It's going to be true only if both conditions are true. Logically, it looks like this in binary. 0 and 0 is false. 0 and 1 is false. 1 and 0. The only one that's true is if both 1 and 1 are true. That's just basic Boolean math. Subnet masks, as I said, it's another 32-bit address. It doesn't have to be contiguous. I've never, ever in my life seen it not contiguous like this, so just assume that it is. I won't say it's always, because somebody will always find an exception to the rule. But in every situation I've ever seen, it starts with ones. It's a series of ones up to a certain point, and then it's some zeros on the right side. So it's all ones to a certain point, and then it's zeros from there on. That's how they do masks. Again, technically, they could do 1 0 1 0 1 0, and it would mathematically work out. And like I said, I've never seen anyone do that. So it's always just all ones up to a point, and you count the zeros at the end, and the zeros are the mask. Here's the rule. Got several examples of this, so just bear with me. I think I can explain it to you. I'm going to apply that mask to my IP address. I'm also going to apply that mask to my target IP address. If the result of my IP mask, my IP address and mask, is equal to the result I get when I apply it to yours, to the target, then you are in my subnet. Again, bear with me on this. So basically, I'm going to apply the mask to me, I'm going to apply the mask to the target. If the results are the same, then we're in the same subnet. We're in the same room here. If the answer is no, I'm going to go out the door, go to the gateway. Here's an example of it. My IP address, 192.168.220.103, and I've taken the 192 and converted each one of those into the 8-bit ones and zeros. You say, do you know that? Do you have that memorized? Can you do that mathematically? Absolutely not. So normally I would not ask you to do this, but we need to see ones and zeros here just so you can understand the masking thing. But if you got a decimal number and you need to convert it to binary, how are you going to do it? Google decimal to binary converter, and about 10,000 of them will pop up. And you just key in a decimal number, you get the binary ones and zeros back. That's all I did. So basically, I just took a number and I converted that 192 to the ones and zeros, the 168, blah, blah, blah. Did the same thing over here. Here's my source, here's my target. 103 and then 221.68, same ones and zeros here. My subnet mask, 255, 255, 255, 0. I'm not going to make you know many of the binary or decimal to binary conversions, but you need to know that one. In unison, what's 255? What's the decimal number 255 in binary? How many ones? 8 ones. I'll give you another one I'd like you to learn. Decimal 0. 8 zeros. Okay? Now, you can play around with the 255, double it, half it, add a 0 or take a 0 away. I'd like you to kind of learn right around the 255 range. But the most important thing is if you know 255 is 8 ones, 0 is 8 zeros. And by the way, when you get most routers, they're going to come with a subnet mask default of that, 255, which is nothing more than 888, 24 ones followed by 8 zeros. But there's nothing magical about that other than the fact that that just gives you a nice, reasonable size subnet. Now, what I'm going to do is I'm going to take that 1 and I'm going to mask it. I'm going to AND it with my mask. 1 and 1 is 1. 1 and 1 is 1. 0 and 1 is 0. Well, hey, I bet you there's a better way. If you look at that real quick, what do you see? If you've got all ones in the mask, whatever's up here just comes down here. You follow me? You can work the math on it, but you can start seeing ones. That's why it's really called a mask. 1, that lets anything up here come on through. A 1, it passes through. What happens if it's a 0? Well, let's pick it up. 1 and 0 is 0. 1 and everything's 0. I grayed it out instead of zeroing it just for explanation purposes. But basically, if it's zeros, then that's going to be all zeros. So 1s pass through, zeros become zeros. You follow me? So what's the result of my source IP address applied with the mask? It's this number right here. So what was the rule? What was the rule again? I'm going to take the source and run it through the mask and get a result. I'm going to take the target, run it through the mask and get a result. And the big question down here at the bottom, are these equal in unison? Okay, everybody shook their head in unison. Okay, the answer is no. Did you have a question? Or
Why isn't 0 and 0 1?
because that's 0 and 0. Is that exclusive or? It's just the AND function. The AND function by definition was that table. 1 and 1. That would say if it's not 3:30, and you're still out of control in the class, then I'll start the class. That would be 0 and 0 would be true. And we don't want that, not with an AND function. But that's just the definition of AND. That's the rule for AND. 1 and 1 is the only thing that becomes 1. The answer here, why is it not correct? Or why is it not equal? What's wrong? Where is it wrong? Where is it different? Where do you see it? Okay. Last two, 0, 0 and 0, 1. Those are not equal. So what does that mean? These two are not in the same subnet. That's all we've determined. Every bit of this was nothing more than to say, is the source and the target in the same subnet? The answer is no. Second example, I kept the same source and the same target IP address, but I grew my subnet a little bit. Instead of 255, I went to 252, which adds 2 more zeros here. So basically, we got 10 zeros on the end. So we're going to mask off what? 10 on this end, 10 on this end. What's the question? Are they equal? They are equal now. We are now in the same subnet in this example. Any questions on this? Okay. Just summarizing all of this, my IP address is 192, blah, blah, blah. My subnet is 255, 255, 255, 0. There's a couple of ways I'm going to ask you this question. I'm going to ask you the question, what is the range of IP addresses in my subnet? And the answer to that is 192, 168, 1. The way you do that is you put a 0 where the mask is, and you put all 1s. All 0s where the mask is to all 1s where the mask is, and that will give you the range. If I ask you for the range, it's 0 to 255. If I ask you for the size, be careful, it's what? 256. 256 is the overall size, but the range, it goes from 0 to 255. And just summarize, any IP address in this range is local. Any IP address that's not in this range needs to go to the gateway. So all I need to do is if I find, I'm going to mask and see, I got to send this thing out. Who do I send it to? Run the mask. Oh, it's in my subnet. I send it directly to the IP address. If it's not, I need to send it to the gateway. And the gateway will handle it all the way upstream from there. Subnets are hierarchical. Talked about my gateway here in the doorway. Well, it turns out that gateway on the other side is playing in a different sandbox. All the hallways on the 5th floor of this building, each classroom has a gateway. On outbound side, all of those gateways are a part of a subnet. They have a gateway. Where's that gateway? I don't know, at the escalator. Heading down to another, all the floors come together. Every floor has an escalator gateway made up of subnet of all the gateways for the classrooms. And then there's another gateway at the front door of CBA, and that gateway is playing, and the entire its subnet is all the escalator gateways. You follow me? See what I'm saying? Onions, layers of onions, just keeps working its way out. So decentralized traffic flow, what happens? If I have to go out to the gateway, well, it turns out it's going to the next classroom. The gateway here realizes that the target IP address is inside the subnet of this floor of CBA, 5th floor of CBA. So it doesn't talk to its escalator gateway. It talks directly to the classroom gateway next door to us. Traffic only goes out as far as it needs to and then comes back down. You follow that concept? Absolutely crucial. Going from Guadalupe to San Antonio, you go as far as you need to go, but that does not include I-35. There's no reason to get all the way to I-35. If you're going to San Marcos or to Georgetown, you need to go to 35. But not unless. That's what we're trying to do, decentralized traffic flow. Now, every computer accessing the internet must have an IP address. No exceptions. That is no new news to you. We've talked about that several different times. Every computer on the network has to have an IP address. But we got a problem. Every computer has to have an IP address. Meaning, we got 25 or so of y'all in this room here. Got an office. Let's say you're my client or you're my people in my room. Everyone here needs to get on the internet. But what do you do on the internet? You call out. Now, my phone broke. I need to borrow your phone. I need to make a phone call and borrow your phone. Did I need to ask you for your phone number? Do I need to know the phone number of your cell phone in order to make that call? When might there be a situation where I do need to borrow your phone and I do need to know the phone number? I need to know what phone number you're giving me here. What situation would occur that would need that?
If you have to tell somebody to call you back.
Precisely. If someone's going to call me back, they need to know the phone number. But otherwise, we don't have to know the phone numbers. So it really doesn't matter what phone number we've got, just as long as we've got a phone number. Frankly, I don't particularly want to buy 25 internet IP addresses from Time Warner for you guys. That's going to be a big expense. Time Warner's going to not be thrilled with me, or they'd be thrilled. I'd be paying them. The rest of the internet community wouldn't be thrilled with me because I just took up 25 more internet addresses just for you guys when it didn't really matter. Nobody's calling you. I mean, it's not mandatory that you know what your IP addresses are. So I said that every computer accessing the internet must have an IP address. What I did not say was that every computer accessing the internet had to have a unique in the world IP address. We've just discussed subnets, where in some sense the gateway kind of helps us isolate ourselves. How about we just pick a range of IP addresses inside here that will just be our own little world? We'll just get our own little range of IP address. I don't care if somebody else has those IP addresses. They're not going out. We're keeping our local traffic local, remember? Subnet keeps local. As long as we're talking amongst ourselves here, who cares what IP address we get? As long as we all agree, we're all work off of this range of IP. We can't. Now, Lisa and Michael can't have the same IP address. We have to be unique within our little sandbox here, but we can still be completely independent of what the IP addresses are out in the real world. Only problem is we do have to go outside every once in a while. The gateway is going to have to do some sort of a mapping or something because we're not going to be allowed to get our stuff out. We got these little private IP address ranges going to mess up downstream. Specifically, here's a picture, our same picture from a minute ago. Inside our classroom here, 192.168.1.100, that computer's at 100, this computer's at 101, that computer's at 102. Fine, but over, across the hall, another classroom, somebody else also has a 100. Notice, same IP address, 101, 101, 102, 102. Same thing down here in classroom 3. So we're just reusing the same IP address on all of these. But notice the gateway. Now, the gateway, I said a minute ago, gateway's 2 computers. Looking in, the gateway's just one of us. There's part of us, and in this particular case, the gateway has the .1, .001, 192.168.1.1 address. Same thing over here. Gateway's the .1, gateway's the .1, all in our little private party. But now, on the outbound side, we got to play in the real world. Okay? Time Warner Cable gave us that IP address and thinks that everything coming down here better be 2433.144.21 because that's the IP address it gave it. All of a sudden, you start sending a .1, 192.168, and that starts coming down here to the internet. What Time Warner's going to say? That's not one of mine. You're not playing by the rules. Patrick?
So why are we going to run out of IP addresses if it seems like there can be almost an infinite amount of...
There are problems. We would have run out a long time ago if there wasn't this situation, but there are limitations of where you can use this. We'll get to that in just a second. Good question, though. Exactly. If we could just do this all the time, it'd be great, but we do hit some problems. I mean, it's good for what it's good for, but it does reach limits. So you see what's going to have to happen here. When you need to talk to Yahoo, and you're 192.168, blah, blah, you're that number right there, and Time Warner gave you this number here, the gateway, if it just passes it on through, your request is going to get pitched. because Time Warner says that's not one of the IP addresses I gave you. You're not playing. So what are we going to have to do? Your address is 192.168.132 in this example. This is the internal private network address. This is called a private subnet. When I send a transmission on the internet, meaning I've got to send something out through Janice, what Janice has got to do, Janice says, whoop, I know we're playing in this little private world down here, but when I go out in the real world, I got to play by their rules. So I'm going to be your agent. I'm going to send that request on your behalf using my IP address. And I'm going to take that request that came from 192.168.132 from one of you guys in here, and I'm going to turn around and I'm going to change that IP address into my IP address. And I'm going to send it to Yahoo as Janice, as the gateway. And Time Warner Cable says, happy, love it, works fine, exactly what I was expecting. Now, one thing we did not talk about, and I don't want to go too detailed into it, but just to let you know that there is something, we didn't go into the details of the packets, just because I don't think that's really relevant, but there is one thing that I want to tell you about. Inside the packet, every internet packet that is sent has an ID, has a unique ID, packet ID that's associated with it. Janice is sitting over here. What happens if, Nathan, Lisa, Michael, Patrick, Julie, everybody sends requests out all at the same time through the gateway? Gateway's got a big whiteboard there with a marker. It's looking at, okay, this ID, okay, that belongs to Michael. This ID here, okay, I'm getting ready to send that one out. That belongs to Lisa. Send that out. Here's another one. This one belongs to Nathan. Send that out. Keeping everything on this whiteboard. Keeping track of everything. And then the response comes back in. Well, fortunately, that ID has been maintained in it. The ID is still there. Janice says, okay, here's a response. Let me get the ID. Okay, that's Lisa's. And converts it back and sends it to Lisa. This is called, and it's at the very bottom, for those of you in the back can't see it, the same title at the top, it's in red at the bottom. Network Address Translation, NAT. N-A-T. Network Address Translation. What does that mean in summary? It converts the, quote, illegal numbers that are not allowed outside our little party, takes our numbers that we're playing in here and converts them all to the gateway's number, IP address, and sends everything out. And then when it comes back, it maps it back to the correct IP address so that it gets back to whichever one of you sent the request to begin with. Network Address Translation. Subnets can be private subnets and they can be public subnets. A public subnet does not translate, it just passes IP addresses. That was my first example. That was the one that I was telling you about before. Private subnets are the ones where we just get our own little private range and play in our little party. So, and just in summary here, if a gateway is configured to perform NAT, translates the IP address going out, it must remember where the various requests came from. That's the whiteboard. And then when responses come back, it reverse translates back to your IP address so it can send it back to you. Okay? Gateways can be configured to perform NAT or to pass the address as is. In other words, you can make a gateway, make a subnet for a gateway using the gateway. You can make it either a private subnet or a public subnet. Most routers, almost every router you buy for commercial, for some commercial use, but definitely for consumer use, your Linksys routers, your D-Link routers, your Netgear routers, all of the routers that you can buy at Best Buy or Fry's, and one that you've got in your apartment, it's doing NAT. And if you look at your IP address, more than likely it's a 192.168 something number when you're in your apartment. I say it's one IP address. Its most popular one is, there's actually three ranges, I think. There's the 10 IP address range is private, and I think 70-something is also a private subnet address range. Why 192.168? Why not 189.167? No idea. I think it's another one of those examples like we talked about the other day where guys were going out for beer one night and they said, what random number can we pick for this? And generations to come will agonize over why the number is what it is. I don't know. But every link-sys router, every D-Link router, all this, the reason you want one fixed, we want all the private subnets to use a particular range, just so it's easy to identify if something's going wrong and it's getting out where it doesn't belong. If you see a 192, 168, anything out on anywhere on the open internet, you know that's not supposed to be there. So that's why they pick those numbers. Okay. That was a nice situation where I said, I don't need to ever call in. But unfortunately, I may need to call in. We got this room, we got our little private subnet, we got our little 192 range here, we're doing this nice little thing called NAT going out the door. Life is good until Michael decides that he wants to host a web server in this room on your computer. And you want people to be able to hit your server just like any other website. Reasonable. And this gets into the problem why, these are some of the limitations of it, but we don't want to prevent that from happening. So what are we going to do? Your IP address is, let's see, 192.168.1.175. That's Michael, you're the first one here, 175. You give that IP address out to your friends and say, that's my IP address. You can get to my server from that. You think that's going to work? Why not? Okay, if they're in the room with you, absolutely, but they're not in the room. In that case, yes, good point. If they're not in the room, why won't it work?
Because it's outside the subnet.
They're outside your subnet. What IP address are they going to need to be hitting to get to you? The gateway. The external IP address of the gateway. They got to hit the outside of our Janus here. Come in with that IP. Now we got there. At least we got to the doorway. But we still got a problem. Janice turns around and says, whoa, got 25 people in here. Got a request for a website. I don't have a web server. I'm a gateway. I don't have a web server built into me. I assume one of you guys in here needs to get that. How are we going to do it? There's a term for this, and it is called port forwarding. And what this means is it's actually forwarding based on port number, if you really want to get technical on what it really means. It doesn't forward the port per se. I particularly like the term, but if you want to understand what it means forwarding to a particular internal private subnet computer based on the port number. What it means is I can take port, what's HTTP again? Port 80? 80? Michael needs to go over to Janice and talk to Janice and say, I've got a server. I've got an HTTP server. And I'm going to be address blah, 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 175. And what I need you to do, if anyone comes to you requesting a web page, I need you to send that to me. Now, I'm the guy. I'm the guy that if you get anything on port 80, you're going to come to me. Now, Nathan runs over there and says, wait a second, I'm a mail server. I'm port 25. So you go over to Janice and you say, port 25s need to come to me. And Lisa goes over there and says, yeah, but I'm a POP inbound mail server, so port 110, you need to send 110 to me. So we can do that in as many ports as you want to set up, but each port can go how many places? One. Had somebody a couple semesters ago, well, could you have it rotate like on a Monday it goes to you and on a Tuesday it goes to, well, yeah, I guess someone could code that. I don't think that would be the wisest human interface implementation. I don't think it's what the client wanted, but assuming you can only go one place, we got a problem. We got 5 of you here. All 5 of you want to be web servers. You all have legitimate web server capability. Michael got the jump on it and went over there and talked to him. What the rest of you going to do? What are the options? That's it. Say it louder.
Use a different port.
Use a different port. What you've got to do is you've got to I got to walk over to Patrick's computer, talk to the web server and say, you sitting in port 80 there, need you to pack up your stuff. Need you to move up a row. You're going to be port 81. You got to move on your computer to port 81. And by the way, Lisa's computer got to move to port 82. And Julianne's computer got to move to port 83. Now, it doesn't have to be, I'm picking sequential 81, 82. It could be any number. You could have 8008 or whatever you wanted it to be. It's got 64,000. Just pick one that's not used. That works. But do you see a problem with this? Somebody's going to come, mygateway.com, whatever IP address hits the gateway at the doorway here, and they go HTTP, mycompaniesgateway.com, whatever, and it hits there. What's the default port? Who's going to get it? Michael. Now, what are they going to have to do if they want to hit Lisa's computer or Patrick's computer? What's the user going to have to do? Put a :81 at the end. :82, :83. It works. Trying to decide what I wanted to ask for true confessions here. How many people accidentally, still after all the times I told you not to, typed in www.jwmhosting.com and left off the mis365.jwm? Okay, no one's going to admit it anyway. But if you did, I know no one did that, right? But what happens? Humans make mistakes. It happens. So what are you going to do? Well, Michael won. Michael's going to get a lot more traffic than probably he needed to get, because people are going to be trying to get Lisa's or Patrick's or Julianne's computer, and they're just going to forget. So do you really want to run a business where my URL is www.2gvp.com:82? Would it work? Yeah, it would work. Business decision, I wouldn't do it. Just because people will not go there. Private subnets are good for outbound. They are, in some ways, if you want to do what you're doing, you can do it inbound. You have to do the port forwarding. You have to do moving ports around if you got more than one sitting at a particular port. Not the most luxurious thing, but it will work. But really, private subnets, that's why, back to your question, Patrick, about why we're running out of IP addresses, is private subnets they're good for what they're good for. And you don't want to do it if you're doing web hosting and stuff like that, or anywhere where people still need to get into IP addresses all the time. Let's talk about configuring a computer for IP. And by the way, just for summary, one more time, if you have a private subnet, there are two additional functions that the gateway has to perform. Outbound, it has to do what? Okay? It has to convert your private IP address into the public IP address. What's that called? NAT stands for? Okay, just kind of get familiar with all that. Inbound, when someone is trying to get into the room here, what's that called? Port forwarding. Okay, that's summary. Okay, now we need to configure a computer for internet access. We've been slowly over the last couple of weeks building up a list of things that each computer really has to have in order to function on the internet. We started off with an IP address, and that wasn't too bad. But then we added the DNS servers, your caching servers we talked about last time, your personal directory assistance servers. And there's two of them. They're typically a primary and secondary. Why do they have two? Why do you think they have two of them? Why do you always have two directory assistance numbers you can call? Yeah, pretty obvious. One goes down. Now, they both go down. That means you have a big problem at your site with Time Warner or whatever. But if they're going to take them down for maintenance, they're only going to take one down at a time. So, yeah, you just have a backup. But you have two of those. And now we introduced two more things today. Two more things you have to have. You have to have a subnet mask. You're not going anywhere without a subnet mask. Every computer has an IP address and a subnet mask. And going along with the subnet mask, if you've got a subnet and everybody is on a subnet, what do you have to have? You have to have a gateway address. In order to talk to the gateway, you have to know the gateway's address. You don't just say, I'll send it to this address or send it to the gateway. It's an IP address. You just got to know Janice's address on your private network. You'll send it either to one of these people in the room or you will send it to that IP address. We got 5 things now. Got 5 things that you have to find out and configure, key whack into your computer to configure your computer to make it work on the internet. Where do you think you're going to get all that information? Just in general, not technical or anything. Are you going to make it up? Anybody think that you can just create? I haven't used this number in a while. I think I'll just pull a number out of the air and I'll put it in here. Anybody think that'll work? Where are you going to get this stuff? Well, technically, yes, that's one way to do it. But in general, in the old days, it's a very technical answer. Somebody got to tell you. Okay? That's as general as you can get. You got to get it from somebody else. You follow me? Somebody got to tell you all of those values. Somebody in authority. Some administrator. Sadly enough, there is no forgiveness. This is not horseshoes. You don't get points for proximity. You get one number wrong, and it is not going to work. I want you to picture a scenario here. Another one of my little IBM stories that I like to talk about every once in a while. Early to mid-1990s, TCP was really becoming more popular. This is about the time that those TCP storms were coming along, as I was telling you about earlier in the class. There were more and more people wanting to get involved with this TCP IP stuff. And IBM was having to get administrators to help us configure and all of this. There's a whole team of people, and their entire job was to administer TCP IP. And they had, I'm sure, these big boards and notebooks and everything with IP address ranges and all subnet masks and everything else, and it was all done manually. We had 5,000 people at our site in Austin here. And these people would have to, either one of two things. The administrators would either come to your office and sit down at your computer with all their information that they've got assigned for you and key it all in, and hopefully most of the time it would work. Or they would give you a piece of paper, back of an envelope with all your information on it. What 5 things? IP address, subnet mask, gateway address, and the 2 DNS servers. Those 5 things. Written down on the back of an envelope. You go back to your office, key it in. And none of us knew anything. I mean, we just have to picture that. Hopefully you could find the field that they told you to put it into, and not where we are today. Can you see the problems here? Oh, and I forgot to mention, IBM and our labs was like, they used to refer to that the walls were on rollers and zippers. They would change offices, they would move things. We would move every 6 or 8 months. We'd reorganize and move to another office, and so it wasn't bad enough that we had 5,000 IP address setups we had to do once. By the time they got to the end, they'd start over. There's one word for this, and it's nightmare. This is an absolute nightmare because, can you imagine, the odds that you could get your IP to work were probably lower than the odds that they wouldn't work. That's a problem. Decentralized administration, does that really meet the objective? Decentralized administration? Okay, we had a small team. What did they try to do? They tried to decentralize it. They had a lot of other teams. And then they tried to make an administrator in each one of our departments to be responsible for it. They were decentralizing the people, but they were not decentralizing the function. It was still a royal pain. Bottom line on all of this, there's one word that killed all of us back then. Manual. We are human. We made errors. We made tons of errors. The people that were trying to do it were better than us, but they made errors. Anytime you have this massive a configuration item and it's having to be done manually, it's a nightmare. So what do we need? Let's go back to the design premise. When do you care to even know what IP address you've been assigned? When do you care to even know what phone number you are using on your cell phone? Only if someone's calling in to you. Do you really need that very often? No, you don't. Not on IP, you do on your cell phone more, but on IP, people don't call you unless anybody in this room running a website out of your laptop here in this room? I don't think so. You running a domain website on your, okay, didn't think so. So none of us do this. So no one's calling in to us. All you really care about is you have an IP address. You got to have one. It's got to be in the right range. It's got to be correct. But you don't care what it is. If it changed every day, you don't care. Any IP address in the right range will do for you. What we need is a way for our computer to automate this entire process. And there is a way to do it. And you need to know this. You used it today. Every one of you who opened your laptop up an hour ago in this room right here used what I'm going to tell you about right now. It's called DHCP. It stands for Dynamic Host Configuration Protocol. I don't really particularly care. I'd like for you to know the words. I'd care that you know what DHCP is. I always like asking the question of what DHCP or all these acronyms stand for, just because I love reading the creativity. People that can match words, make up words for the letters on tests. But no, you're not going to live or die whether or not you know that the D stands for dynamic or H stands for host. But I need to know DHCP because this is a huge function. It is very pervasive. DHCP requires a server. DHCP servers are put on the subnet. Now, often the gateway is also the DHCP server, but for sake of our discussion, I want to separate those two because it doesn't have to be. We have a different server, a different box. I go over here in the room and I create a computer and I go get some software, DHCP code. DHCP, and now it actually runs at a lower level protocol because you're going to say, well, if you don't have an IP address, how can you start? So it's kind of a chicken and egg thing. But it runs not on actually at the TCP IP layer, but a layer below. I don't get into the details of that. Just know that there's this low level protocol. It doesn't do a whole lot, but it works for this. But basically what happens is that server is configured with a range of IP addresses to assign. If I got 100 of you guys and I got one guy over here, I'll bet my odds on this one. I'll work on this one, make sure I get it right. It gives me a lot better chance. I can make a mistake on any one of you guys configuring. If I'm doing it all manually for you, I'll work on this one. I'll configure this and get it right. So I set up a range of IP addresses on the DHCP server that I'm going to hand out. I define a subnet mask on this, and I'm going to say, you give that subnet mask to everybody. We all better be playing by the same subnet mask. Because if I think you're in my network and you don't think I'm in yours, we're going to have all kinds of problems. So we want to make sure the subnet mask is identical for everybody in our subnet. So the gateway IP, the gateway IP address, it's not the DHCP server, it could be the gateway, it's a different box. But the gateway, I need to know the IP address because we all need to know who to talk to if we're going outbound. I have to configure that. And then finally, I configure the two DNS server IP addresses that I'm going to give you. Those 5 things. You came into this room and opened your laptop. The first thing your laptop did is say, my goodness, there's a network out here. Any DHCP servers out there? I'm here. I need something. Looking for a DHCP server? Anybody out there? And our DHCP server says, that's me. I'm here. DHCP server says, I've got some information for you. Writes it on the back of an envelope, quote unquote. Sends it down to your computer. And your computer takes all that information, configures it all into itself, and comes on the network. You've seen this every single time when you connect to what does a wireless network say? What's the words that you see all the time? Acquiring network address, or words to that effect. What's it doing? It's finding the DHCP server. It gets the information. The DHCP server makes sure not give out the same IP address twice. It knows how to do all of that. It gives out different IP addresses. All of a sudden we have a power failure. Everything comes down. Everybody comes back. Everybody comes back online. Everybody got different IP addresses. Does it matter? No. Doesn't matter at all. So as long as you got a valid IP address and the DHCP server gives out the right ones every time, have we helped the problem? Absolutely. When would you maybe not want to do DHCP? Dynamic IP address. Mike?
When you want a static address.
When you want a static IP address. Why would you want a static IP address? You hit it. Exactly. If people are calling you, you better get a static IP address. Time Warner Cable gives you dynamic IP addresses. DHCP. Unless you pay for business class. You pay for business class, you get a static IP address. Remember, go back to our physical layer discussion, second day of class. We talked about that. Static versus dynamic IP addresses. Normally, you just get a dynamic. You pay more for a static because they got to go in. Then you got to go in there and manually configure. If you want static IP addresses, DHCP doesn't play. You want static IP addresses, then you got to open your Windows network card configuration, and you got to key all this stuff in. What 5 things do you key in? Same old things. IP, subnet mask, gateway address, and the 2 DNS servers. Key them all in. So we're back. In those situations, you're back to doing it all manually in the back of the envelope. When would there be a situation where you would not want to enable DHCP? All of a sudden, I got my company here, and everybody says, I'm not getting DHCP, and I say, I don't have it turned on. You can't get DHCP. I don't want you to. What's the scenario? When would that happen? Why would I ever want 100 people or 25 people in my office and not allow DHCP, where I have to then hire somebody to manually configure every one of yours? When would that happen? Scenario? Why would I not want to use DHCP?
Is it some kind of security issue?
That would be exactly it. Exactly it. Security. What happens if I got 25 people in my office and somebody just kind of slips in the back, happens to be from a competitor company, opens up the laptop, DHCP, hi, I'll give you an IP address. Sure. A student a couple, 3 years ago that worked in a school system, they would not do DHCP. You had to go in and you had to request and they had to manually configure everything because they didn't want to risk security intrusions. Now, what UT does, they put a layer above it. They intercept all the ports, and you have to log on, and everybody's done this, your standard logging in. They'll go ahead and let anyone get an IP address, but you can't get through anything until basically you have a guardrail right above it at a different layer on IP, and then they block all the ports until you've logged on. Typically, DHCP, turn it on, anyone and everyone can come in and get an IP address. A couple more things will be done. Typical off-the-shelf routers are, fortunately for this, in those little bitty boxes that you buy, shrink-wrapped, D-Links and the Netgears and all that, every one of you has one. The Wi-Fi, they do Wi-Fi. They're the subnet gateways. They are the Janus. Think about it. On the back side of that, you got an Ethernet plug that probably plugs into your cable modem or your DSL router. On the other side, they've got probably some Ethernets and the Wi-Fi, so that's the subnet inside. So you got the two sides, that's Janus. That little box performs NAT functionality. It does port forwarding functionality, and they are also your DHCP server. All one little package, all combined together. And they also, the wireless, we kind of skipped over the Wi-Fi stuff, but what happens when you power up your laptop, the first thing it does, the Wi-Fi is at a different layer. The Wi-Fi kind of syncs up and gets the security stuff all set up for Wi-Fi, and then it calls out to the DHCP server. So it works if you just plug it into an Ethernet port, hardwired, or if you power up Wi-Fi. Either one, same functionality. Any questions on that? Last thing I want to do is I want to take you through 2 or 3 pictures of my router in my house, just to show you practicality. This is exactly what you're doing, whether or not you've configured it precisely. Everything we've talked about today happens every single time you power up your computer in your apartment or whatever. To access the router, if you haven't done this, most routers work this way. On the inbound side, on the subnet side of our gateway here, it has a little HTTP server, little port 80 web server. Doesn't do a whole lot. It serves up a few pages, but that's how you can get in and configure it. So if you hit the IP address port 80 with your browser, you can bring up and that's what I'm going to show you, a few screen captures of that. And by the way, most routers always take the .1 and the subnet. They take the private subnet. They take the .1. Does it have to be that? No, it doesn't. But don't change it unless you have to. I've gone into offices where they've changed it, not having a clue what they did, and it's a royal pain. So if you have to change it and you know what you're doing, go ahead and change it. But typically, just leave it as the .1. So, but basically, if you get a brand new router and you just plug it in, you type HTTP 192.168.1.1, it'll bring up a web page, and I got a couple of web pages here. This is just my Janus configuration here. Notice up and down instead of sideways, but looking up is the internet version, looking down is the network. And notice I've told my router I use DHCP with Time Warner. I don't have a fixed IP address. If I did different type, it would change the form here, and I'd have to key in all the IP address and stuff. But I'm telling Time Warner, my internet setup, get me all the stuff you want to get me to DHCP. Down here, got my network set up, local IP address. This is the IP address of me, the gateway. This is the .1. This is how you're going to find me. Here's my subnet mask. Well, I drop down the subnet mask, and notice they don't allow me to put all ones and zeros and everything in there. They just give me a few options here. Actually, I can't go more than 256. They'll let me drop down. This is actually removing zeros. That's 7 zeros, 6 zeros, 5 zeros, 4 zeros. I keep making my subnet smaller. The biggest one they'll let me do, just because of the way they configure this by preset. I pick the standard. What's the standard one that almost everybody uses? 255, 255, 255, 0. It works. Looking now, after I have actually connected to Time Warner, here's the IP address they gave me. They gave me a subnet mask. This is Time Warner. That's, again, the outer subnet. I've got a subnet mask in the room, and then there's a hallway subnet mask for the other side of the gateway. This is the Time Warner. Notice that's 255, 255, 240, 0. That's like, I don't know what 240 is, how many zeros that is, but that's something like, maybe 2,000 or 3,000 subnet mask. My subnet in my neighborhood in North Austin is a much bigger. It's bigger than 256. It's probably, 2,000 or 3,000, whatever that 240.0 is. Default gateway, that's the gateway upstream for Time Warner, and then the 2 DNS servers. 5 things that you get. They call this port range forwarding. All that means is when you configure that router, instead of just saying make this port go here, make this port go here, you just say from this port number to this port number, forward it. From a range of ports forward to here, a range of ports forward. And if you just want one port, you just make it beginning and end the same number, which is what I've done. Well, you say I may have not been all that practical. I mean, why would you want 5 HTTP servers inside a little subnet? Well, maybe not with HTTP. Maybe that was not a good example. But remote desktop, I have 4 computers at my house. I need to get to all 4 of them at any one time or another with remote desktop from my office here at UT. So I've got a little problem here. What's the port number for, anybody remember port number for remote desktop? 3389. Very good. Will not be on the test. 3389 is the port number for remote desktop. Well, one of my computers wins. One of my computers gets port 3389. But if I want to get to the other 3 computers, maybe I don't have HTTP servers and all that fancy stuff, but I still need to hit 4 different computers technically on port 3389, which I can't do because only one computer is going to get it. What do? Exact same thing. I got to go to my second computer, go over here and say port 3389, remote desktop, pick up your stuff and move to 3390. And then go to another computer and say move to 3391. Another computer, go to move to 3392. How do you do that? You Google it and figure out exactly how to do it and what the key is. You go to, it's a registry thing. You got to go change it, but you can go change it in the registry and you'll move your remote desktop port. And then see what I've done now. I've got remote desktop, and I say just start and end. I don't forward ranges. I just forward single ports. So 3389 to 3389 goes to 220. 3390 goes to 221. 3391. Blah blah blah. And I actually have a couple others. We had to use NetMeeting a lot when I was at IBM. If I use NetMeeting, you know what that is? That's where you can share your desktop and people, you have a big meeting and everybody can see, if you're doing demos on your desktop or, PowerPoint or whatever. NetMeeting, it takes 2 ports, and I had to do that. But bottom line on this is I got computers behind in a private subnet, and I've got certain situations where some people need to call into me. I have to go configure all of this stuff. Last chart of the day, and this is the teaser for Thursday. We're going to start talking about one of my favorite topics, security. Thursday and next Tuesday, a 2-parter on security. We're going to talk a little bit about WEP and WPA security and this type of stuff. Again, if you haven't locked down your router, please go home and do it. Save yourself a lot of heartache and pain. But anyway, we'll talk a little bit about WEP toward the end of the security stuff. We have all kinds of security stuff on Thursday. If you have any questions about this, please see me. Please sign up for the lab and sign up for your paper or for your term projects. And please put your information into those term projects for your topics and all that. So, any questions? We will see you on Thursday.